Okay, section 6.2, question number 6. We want to graph the function not by plotting points, but by starting from the graphs below. So we have a function g of x which is equal to 5 to the x minus 3. So we have to decide, okay, which graph are we going to look at? Well, we need to look at the one that would be the parent function for this. And that parent function would be the one with the same base. So if we take a look at this, the base is 5, so therefore we're looking at this base here, which is 5 to the x, and that's the one that's in blue. So that's the graph that we want. Now, the best thing to do is we want to make sure we can graph this. So one way of what I did is I used Desmos, and I graphed that function, f of x, which is equal to 5 to the x power. Okay, and then I'm going to graph that. And so when I graph that, I want to then pick out a couple points on that graph that I know for sure. I know that 0, 1 is on that graph, and I know that 1, 5 is on that graph. And I'm going to use those points so it can help me figure out how to graph the new graph. Okay? So in this scenario, we're going to give an exponential function, and then we're going to graph a translation. So we're going to draw the horizontal asymptote at y is equal to d. So in this scenario, the value of d is 0. So since the value of d is 0, then the horizontal asymptote is y is equal to 0. Then we're going to identify the shift. And the shift of the graph in this scenario is left c units if c is positive and right c units if c is negative. So if you notice up here, we have x minus 3. And therefore the value of c is going to be plus 3, which means that we're going to be moving it to the right 3 units. So now what we're going to do is then we're going to use our ordered pairs. So our ordered pairs is going to help us be able to shift this graph according to the translation. So we know that the point 0, 1 needs to be shifted to the right 3 units. And if that's the case, then that means I'm going to have to add 3 to that 0 to make that x coordinate, that new x coordinate 3, but the y value remains the same. Likewise, with the point here with 1, 5, we're going to add 3 to that because, again, we're shifting it to the right 3 units. And therefore, now we're going to get a new x value of 4. And therefore, we have now the two ordered pairs, 3, 1 and 4, 5. So therefore, you can see that on the graph. And then what I did is I just wanted to make sure that I can plot another point. And again, this is arbitrarily up to you. But it's just good to be able to do that. So we know that there's on the x-axis there's a value of 2, so I'm going to plug 2 into the function, which gives us 5 to the 2 minus 3, which equals 5 to the negative 1, which is 1 over 5. So then we can plot that 2 and then 1 over 5, and then if I create my smooth curve through those points, then you can see that it's shifted over 3 units. So rather than making a table, we can go ahead and do that way. Now, we want to state the domain and the range. Well, the domain is going to be all the x values on the x-axis because we can plug anything that we want into the x value, so it's negative infinity to positive infinity. And then the range is going to go, so let me go ahead and highlight that again. So the domain represents the entire x-axis. So it's going from negative infinity to positive infinity. And then the range is going to go from 0 to positive infinity. So this graph is going to go from 0 to positive infinity. And then we determined what the asymptote was, which was y equals 0.